Okay, College Trig, you have a test this week. First and third hours, yours will be Thursday, April 16th from 10 to noon. Fourth hour, yours is Friday, April 17th from 10 to noon. If that 10 to noon time frame doesn't work out with you, I mentioned in the syllabus, then you need to let me know. Hopefully it will. If you need to talk to somebody about making that time available, please do. It's only very few times during this year they'll ask you to be present during a very specific time. And so if you make that happen, please do. If you can't, then please reach out to me immediately so we can figure that out. It's going to be 4 problems. You're going to copy the problems down. You're going to do them your own handwork. 2 problems per page. So make sure that you leave space and make sure that you write out your work so I can see your work. Write legibly. Take your time. I'm giving you 2 hours for just 4 problems. So I want to make sure that you can display your work so that I can read it, I can see it. Take a picture and paste it into the Google Doc and submit it via Schoology. A lot of people have submitted things different ways. I won't go through all the different ways that people are submitting stuff, but what is most helpful to me? Yes, it is that you take a picture and paste your work and put it into your document for your homework and submit it via Schoology. That is by far the easiest way. Otherwise, I have people's homework all over the place that I'm looking for, and I've been able to find it and keep up with it, but yeah, it is inconvenient. Yes, it's inconvenient. There's an app on your phone if you want to download called Cam Scanner. Apparently, people have let me know that it's taking excellent pictures of their homework, heightening the quality. Remember, this test is open note. It's open homework. It's open class videos. It is not open phone. It's not open internet. It's not open partners. So, I'm not sitting there with you guys. Just understand that teachers present, and I do, assuming that you're going to be honest through the situation. I would just ask that if you hold to your ability to try to cheat through things, and make sure everybody's aware that you're a cheater and that you don't like to do your own work and that you like to benefit off of the work of others. Let everybody know that so that we know exactly what your intentions are. So if you don't let me know that you're a cheater, I'm assuming you're doing this honestly, as I'm trying to make sure that you can do it in a very fair way. Okay. So this is a review. I'm going to go over a couple problems for you. I only have 15 minutes for this video, and we are currently 2.5 minutes in, so I'm going to try to do this as quick as I can. We're going to place these 2 complex numbers in a trigonometric form. So 4 plus 4i, and the second problem we will do 1 minus I roots of 3. We're going to turn those into trig form. In order to turn them into trig form, you need your radius value and your theta value. R is the square root of 4 squared, or 16, plus 4 squared, or 16. I get the square root of 32, which reduces to 4 roots of 2. In order to find theta, I set up tangent of theta is equal to my b value, 4 divided by 4, which is 1. And so tangent is equal to 1 both at 45 degrees and at 135 degrees. If you were to plot 4 plus 4i, that would put you in the first quadrant. So therefore, this is a 45-degree angle. We do turn this into radians. Make sure your answer is expressed in radians, which is pi over 4. So therefore, trigonometric form is the following. 4 roots of 2 times the cosine of pi over 4 plus I sine of pi over 4. There you have it. The next one, r is equal to the square root of 1 squared plus the root of 3 squared, which is 3. And that will be the square root of 4, or 2. To find theta, we set up the tangent of theta. Whoops, sorry about that. Tangent of theta is equal to negative root of 3 over 1. So where is tangent equal to the negative root of 3? Remember that root of 3 is a 60-degree angle. And so, where is tangent negative? Is tangent in the second quadrant and the fourth quadrant. Well, if you were to plot this, that would put you into the fourth quadrant, over 1 and down the root of 3. So we're looking at a 60-degree reference angle here in the fourth quadrant, and that makes 300 degrees. 300 degrees, or in radians, 5 pi over 3. So you have 2 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. And that's what you have, okay? So there's 2 examples. We're going to do 3 more, but those have, in fact, put you in a good shape to be able to turn things from complex form into trigonometric form, okay? The next problem that we're going to look at here is we are going to find, given z sub 1 is equal to 3 times the cosine of pi over 6 plus I sine of pi over 6. And z sub 2 is equal to 4 cosine of pi over 2 plus I sine of pi over 2. So I have those bits right there, okay? So I'm going to find z sub 1 times z sub 2. And what you should remember about multiplying complex numbers in trigonometric form, you multiply the radius values. So 3 times 4 is 12. And then what do you do with the, got parentheses around that stuff. What do you do with the angles? You add them. So we're looking at pi over 6 plus pi over 2. Pi over 6 plus pi over 2. Let's create common denominators of 6. So I have pi over 6 plus 3 pi over 6. That would give me 4 pi over 6 or 2 pi over 3. 2 pi over 3 plus I sine of 2 pi over 3. Again, this is the type of work that I want to see on your test. I don't want you just, I'm not giving you 20 problems that you got to figure stuff out for. Make sure I see where your work is coming from. And try to write in order. Sometimes you guys like to put answers here, there, here, there. That may be the way you are. You need to change it so it becomes more legible. People can follow your work. You need to be professional about it. Okay, the next one, we have z sub 1. We're going to do divide by z sub 2. And we do z sub 1 divided by z sub 2. You take your r values and divide them. 3 over 4 times the cosine of, and now you're going to subtract. So we have pi over 6 minus 3 pi over 6, which is negative 2 pi over 6, or negative pi over 3, plus I sine of negative pi over 3. So 3 over 4 times the cosine of, what happens to negative there? It disappears because cosine gets rid of negatives, and then the negative for the sine dumps out front minus I sine of pi over 3. If you don't remember that, please reach out to me. We can talk about it or go over another video together. But that was from earlier that we learned that skill. Okay, and then the last one, de Madre's theorem. Taking these things and raising them to a certain power. So, for example, suppose you were going to take 1 minus I roots of 3, and you're going to raise that to the 4th power. Well, that looks familiar because that was one of the examples we just did of turning into trig form. So just first note that you have to put it into trig form, and in trig form, that is 2 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. Now, as you raise it to the 4th power, what you do is you take this number and you raise it to the 4th. You take this number and you multiply it by 4. So we get 16 times the cosine of 5 pi times 4 is 20 pi over 3. Okay, now it becomes a little bit more interesting. 20 pi over 3 is more than once around the circle. So we're going to subtract off 2 pi. 2 pi is the same as 6 pi over 3. So I'm going to subtract off 6 pi over 3's. Subtract 6 pi over 3 and you get 14 pi over 3. Subtract it again and we get 8 pi over 3. Subtract again, we get 2 pi over 3. So 16 times the cosine of 2 pi over 3 plus I sine of 2 pi over 3. Great, we've got it. Now that we have that piece, that's what we call trigonometric form. You must have answers both in trigonometric form and in complex form for your test. As I turn it into complex form, watch what happens. 2 pi over 3 is a 120 degree angle, which has terminal points of negative root of 3, or negative 1/2, and root of 3 over 2. Cosine is the x value. That means that you have 16 times negative 1/2 plus I times root of 3 over 2. Now that is complex form. The fact is most people wouldn't write it like that. They would actually take 16 times negative 1/2, which is in fact negative 8. And then they would do 16 divided by 2 here, which again would be 8. So that would be plus 8I roots of 3. So that is my preferred version of complex form. I would accept either one of those, but that is nicer, and that's what your book would list and most people would list. So what do you get if you take and multiply that out 4 times? You get that. Now you're saying, well, that's no big deal, Mr. Gintz. I could actually multiply it out 4 times. Good for you. You're very impressive. Pat yourself on the back. What if I give you something like instead of the 4th power, we give you the 40th power? Now that's where de Madre's theorem comes in real handy. So we're going to do one last one here. I've got 4.5 minutes to get this done. 1/2 plus the root of 3 over 2 raised to the 20th power times I, raised to the 20th power. So that's a little bit more difficult. We are going to take that and put that into complex form. So we need a radius value, which would be the square root of. If I square 1/2, I get a 4th. If I square the root of 3 over 2, I get 3 over 4. That gives me a result of 1. That's a nice R value to have. We're going to make great use of that. Theta, we do tangent of theta is equal to B divided by A multiplied by the reciprocal. So tangent's equal to the root of 3. Where is tangent equal to the root of 3? Well, that's at a 60-degree angle. Is that in the first quadrant? It is. So 60 degrees, or rather theta is pi over 3. So I have complex form. 1 times the cosine of pi over 3 plus I sine of pi over 3. But what we want to do is we want to raise that to the 20th power. So you take 1 and raise it to the 20th. And then the cosine of pi over 3, you multiply that by 20. Sine of pi over 3, multiply that by 20. What do you get? I to the 20th, or 1 to the 20th is just 1. Cosine of 20 pi over 3 plus I sine of 20 pi over 3. Does that look familiar? Yeah, just like from our last problem, we're subtract off that 6 pi over 3. We did that and we came up with 2 pi over 3. So 1 times the cosine of 2 pi over 3 plus I sine of 2 pi over 3. And that's what you call trigonometric form. Complex form, simply find the terminal points, which we already did, and we get 1 times negative 1/2 plus I roots of 3 over 2. Now, I would distribute this 1 through here, and so I get negative 1/2 plus I roots of 3 over 2. And that's complex form. I need to see both. We went through it here. We did about 5 problems. You're going to have fewer than that when it actually comes time for your test. You're only going to have 4. Thank you for your hard work. Thank you for those of you who've asked and reached out for help. I've enjoyed visiting with you. Please make sure that you just have your work legible. If this time issue does not work for you, the 10 to noon, please reach out to me sooner than later so we can work something out. But just want to make sure that people have a certain time that they're working on it. Just test security and just making sure people are hopefully doing what they're supposed to do. So thanks. Have a great week. Later.